All right, this is Chapter 5, Lesson 4, called Comparing and Graphing Ratios. So, looking at a couple of different things today, our learning target says I can compare and graph ratios. We'll enter that into our journals, and we need to be on page 212 in our math books. So, we'll write out our learning target. I can compare and graph ratios. So this whole chapter is really focusing on this word ratios, comparing two quantities, and we're really going to be comparing today because that's in our learning target. So at the top of page 212, there's really no crazy vocabulary. We're going to take what we've learned so far in this chapter and just use it now to compare some things. So we're going to get right to our examples. Okay, example 1. It says you mix 8 tablespoons of hot sauce and 3 cups of salsa in a green bowl. You mix 12 tablespoons of hot sauce and 4 cups of salsa in an orange bowl. Which mixture is hotter? So we want to figure out, okay, there are 2 different ratios here. Which one is going to end up having more hot sauce? Because it's going to be a little more spicy that way. So let's write out what we have. So here we're going to be comparing ratios. We're comparing the 2 ratios that they give us for hot sauce. So there are 2 different bowls. One of them is the green bowl. And underneath the green bowl heading, we're going to say there's 2 tablespoons of hot sauce. Or excuse me, 8 tablespoons. 8 tablespoons, TB for tablespoons, of hot sauce. And then along with that hot sauce, there's 3 cups of salsa. Now, salsa can be spicy too, but really it's the hot sauce that probably makes things really spicy. So that's what we're going to focus on, which one has more of that. So we have the orange bowl next. And inside the orange bowl, it tells us that there are 12 tablespoons of hot sauce and 4 cups of salsa. So the question we want to know is which one is hotter? Now, some kids would look at this and go, oh, well, it's the orange bowl. Duh, because there's more cups of hot sauce or tablespoons. However, there's also more cups of salsa in this bowl that would kind of take away the hotness from the hot sauce than this one. So we have to do a little bit of math thinking and convert both of these ratios into unit rates in order to accurately compare them and see which one does in fact have more. So instead of 8 tablespoons for 3 cups, we're going to figure out how many tablespoons for 1 cup for the green bowl and how many tablespoons for 1 cup for the orange bowl and compare those two. So the first thing we'll do is take 8 tablespoons of hot sauce and divide it by 3 cups of salsa. So 8 divided by 3 on our calculators would give us 2.6. So that gives us 2.6 tablespoons per cup. Excuse me, that's the wrong spelling of cup. per cup of salsa. So that's how many per cup of salsa. Now, if we do the same thing over here, 12 over 4 or 12 divided by 4 gives us 3. So we have 3 tablespoons of hot sauce per cup of salsa. So if we compare the 2.6 versus the 3, well, there's more hot sauce in this one. So the orange bowl still wins. Even though there's more cups of salsa, it is still going to be much hotter. So which one is hotter? We're going to say the orange bowl is going to be a hotter mixture with that salsa and hot sauce. Now we're going on to example 2. So looking at example 2, it says, which bag of dog food is the better buy? And so let's look over to the left. And if I'm looking correctly, it's telling me that a 20-pound bag of dog food or 20 pounds of dog food is $17.20. And then underneath that, it says a huge 30-pound bag of dog food is $25.20. And when we're looking at which one is the better buy, we have to divide these out to figure out how much we're paying per pound in order to really determine which one is the better buy. So writing down what they give us, we want to know which one is the better buy. I'm going to underline or box that in because you're going to probably have something on your unit test that's going to ask you about better buy. So you're going to want to look back at this question when you're trying to figure that out. And we're looking at dog food on this one. So looking at the left, let's write down the information they give us about the pounds and the dollar amount. So they're telling us that there's 20 pounds, and pounds is labeled with an L and a B. So 20 pounds of dog food for, and looking at that picture, it says $17.20. So that's our first comparison. And then the second comparison is 30 pounds of dog food for $25.20. So really, you can't just look at them right now and figure out which is the better buy. We have to divide these out and figure out how much we're paying per pound here, how much we're paying per pound here to figure out which one is actually cheaper. Now remember, the better buy, you're going to be looking for which one is the cheaper one or which one has a lower cost. You're not trying to look for a higher cost. I don't know about you, but if I saw two things and one was higher, I'd probably go for the one that's cheaper or less money. So this first one over here, remember when we're dealing with dollars, we always put the dollars in our calculator first. So we're going to put our 17.20 over 20 pounds. There's our comparison. So in our calculator would be 17.20 divided by 20 pounds. And in your calculator, if you do that work, 17.20 divided by 20 pounds. Oh, I did a little differently in my book. So I'm going to grab my calculator. $17.20 divided by 20 pounds is going to give us 0.86. And that's not quite a dollar, so that's 86 cents. So 86 cents per pound is what we're paying over here. All right, so let's do the same thing on this side. Remember, our dollar amount goes on top. So we're going to put $25.20 for 30 pounds. So in our calculators, we would do 25.20 divided by 30 pounds. 25.20 divided by 30-pound bag. That would end up giving us 0.84. So very close, but this one is 84 cents per pound. So if I'm comparing these two prices, I'm actually getting more for my money over here on the 30-pound bag than I would be getting for the 20-pound bag. So if I really wanted to save money, knowing that I have to probably buy more dog food later, the 30-pound bag is going to be a better buy. So I'm going to put down here, better buy, 30-pound bag of dog food. Because my money is going to go farther and get me more pounds of dog food if I buy that, because it is cheaper. You can pause the video and go ahead and try the two on your own at the bottom of page 212. All right, so number 1, the answer would be the one in the green bowl. For a batch of each mixture using 12 cups of salsa, the green bowl would have the least amount of hot sauce. And for number 2, you would pick the 32-pack. The unit cost of the 32-pack is $1.55, and that's less than the unit cost of the 30-pack, which is $1.61. Now we're moving on to example 3. Shift this down a little bit here. Example 3 says graphing values from ratio tables. So if you have a grid in your notes, this is going to be helpful. If not, you can try to do this with just your lined journal, or you can grab a piece of graph paper, make this little graph, and then tape it into your journal. Either way, that's fine. A hot air balloon rises 9 meters for every 3 seconds. And then a blimp rises 7 meters for every 2 seconds. So it looks like we're comparing a hot air balloon here to a blimp. First thing they want us to do is complete the ratio table for each aircraft and then tell which rises faster. Then it's wanting us to graph all of our ordered pairs for the time and the height from the tables on a graph, and then kind of talk about what we see there or what can we conclude. So first thing we'll do is write down the information they've given us. So the first thing they have is a hot air balloon. And the hot air balloon, it rises 9 meters for every 3 seconds. So I'm going to put 9 meters to 3 seconds. And then we can go ahead and fill out a little ratio table. So we can compare the time versus the height. So let's put the time here and the height here. And so if the time is 3 seconds, then my height is going to be 9 meters. And I can just keep that pattern going a few times. So we've got a 6. So if I go from 3 to 6, my 9, well, let's see, if I'm adding 9s each time, this is going to be an 18. Then I have 9 and 12 at the top. So if I keep adding 9s on the bottom, 18 plus 9 would give me 27. And then add another 9, and that would give me 36. So every 3 meters of increase in time, my meters or my height are going to be increasing by 9 based upon my rate that they gave me at the top. The other thing we're comparing is the blimp, so we'll put that over here. They tell us that the blimp is going to rise 7 meters for every 2 seconds. 7 meters to 2 seconds. So if I'm going to do time and height in my table, so we have time being 2 seconds and 7 meters. Then time could be 4, 6, and 8 seconds. So the top is increasing by 2 seconds every time. The bottom would be increasing by 7 every time. So 7 and add another 7, that would give me 14. Add another 7, which gives me 21. And then I've got 28. So as the time increases by 2s, my height is increasing by 7s, because that is what our ratio told us at the top. So in the question, kind of going back and making sure we're answering everything it's asking us to. Question A says, complete the ratio table for each aircraft and which rises faster. So if I'm looking at this, 7 meters for every 2 seconds versus 9 meters for every 3 seconds. If I wanted to really figure out which one goes faster, I have to figure out, okay, well, is there anything that I can compare on these two? Well, if I look at this column right here, 6 seconds, the height of this hot air balloon is 18 meters. And if I look over here, there's also a 6 seconds on the blimp's chart. 6 seconds here, and my blimp is at 21 meters. So if my hot air balloon is only at 18 meters and my blimp is at 21 meters, I'm going to say that the blimp rises faster, because at the same number of seconds, my blimp is higher. So the last one here for the lesson is going to be asking us to graph these items on an actual graph. So what we're going to do for question B is set up a y-axis as straight as you can. Let me zoom down here. And an x-axis so that we can take these ordered pairs that we've created on our tables and put them on a graph. And so if we make this graph, we're going to have this bottom represent the time. These are going to be our seconds. And the y-axis is over here is going to be our height in meters. So we have 0 seconds. And if we look over at our numbers, our time here goes 2, 4, 6, 8. And our time here goes 3, 6, 9, 12. We're actually putting both of these graphs on the same little x and y axis. So I'm noticing that my highest number is 12. Let's just go by twos. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. So there's our time. And now our height, let's see our highest number on our height. We've got 36 here and 28 here. So we have to decide what we're going to go by up the side for our height. We don't want to probably go by ones because I have to get all the way to 36. So maybe we go by threes this time. Or fives. Let's go by fives. 5, 10, 15, 20, 25 meters, 30 meters, 35 meters. What was our highest again? 36. So let's make it going up to 40. So kind of practicing how to make a graph. So let's go ahead and plot 3 seconds and 9 height. So 3, 9 is going to be our first coordinate. So down here, we're going to go over to 3. Well, here's 2. So 3 would be right in the middle between 2 and 4. So at 3 seconds, this hot air balloon is at 9. So here's 5. 9 would be right underneath the 10, and we'll make a dot. Whoops. That's not what I wanted. Okay. Well, there we go. There's our dot. The next one, we scroll back up, says 6 seconds and 18 for our height. So we're going to go over to the 6 seconds and up to 18. Well, here's 15. There's 20. So 18 is going to be a little bit underneath that. The next one in our chart says 9 seconds and 27 for our height. So 9 seconds would be right in between the 8 and the 10. 27 would be right about here. So we'll make a dot. Then we have 12 seconds in that last chart, and we have 36. So over to the 12, 36 would be about right there. And then what we can do is kind of figure out, oh, look, these dots kind of create a straight line. They're going upward in a straight line. Now let's go ahead and plot the blimp. I'm going to actually change colors. If you don't have 2 different colors, that's fine. You can use a different kind of line to be able to see the difference. So we have every 2 seconds, it's going up 7 this time. So let's plot that one. So at 2 seconds, it's at the 7. So there's 5 and there's 10. So 7 would be right in here. 2 more seconds, it's going to go up 7 more. So that's at 14, right underneath the 15. 2 more seconds, we have to add 7 more. So that would be 21. 2 more seconds, at the 8, we would have a 28. So if I connect my dots this time, I get another straight line like so. So there is my graph. My green one, or my second line here, is my blimp. So I'm going to put blimp. My red one there is going to be my hot air balloon. So I'll label that hot air balloon. And the question kind of says, okay, make the graph, and then what can you conclude? Well, if we look at our 2 lines, earlier we said that the blimp was faster, and our lines show that too. The blimp is faster, because if you notice, the blimp has a steeper line. It goes up quicker than our hot air balloon. So we can say that the blimp is faster because it has a steeper line. So you're basically just confirming our previous answer that the blimp is faster because our line travels up a lot quicker than our hot air balloon. It's a steeper hill than our hot air balloon line. If you'd like to try the on your own at the bottom of 213, you can go ahead and pause the video and do that now. So for number 3, the two graphs now coincide because the rates are equivalent. So both rise at the same time. That would be our final answer. And that brings us to the end of lesson 4.